Welcome back to session 3. Raymond, how are you doing?
I'm doing great.
So in the last session, we finished it up with a refactoring, and that
Yep.
we kind of liked, but then we had to finish. So my question to you is, do you want to continue to do some more refactoring? Because I also got some comments that the code is still not readable enough. Or do you want to continue and do some more stuff?
What did they say was not readable enough?
Specifically, I think someone mentioned this flag right here. What do you think?
I think it's fine for now.
Okay.
I think we should continue.
Okay. And let's get rid of this toolbar right here again. Is it the text editor? Yeah.
Yes.
I didn't know that NUnit had a toolbar.
No, I made it myself.
Oh, what happens when I click it? I just clicked.
It launches this one.
Ooh.
Because I wasn't using test runner.
Oh. How hacky of you. That's pretty cool. Let's see what happens. Nice. I like the green feeling there.
Yeah.
Okay. Okay, so let's open up the Excel file and see where we're at and where we're trying to go.
Okay, so oh, I didn't open it. So we were trying to we were working on the territories, and then we decided to do a refactoring.
And I got a comment about the territories that it's actually called chains.
No, they're actually talking about what I called groups. So when I said surround group,
yeah,
they're actually talking about surround chain.
Mm-hmm. Okay. So
we could read
we're in the middle of something, or were we just finishing? I think we're just finishing the winner, or we're just beginning the determine winner with some features.
So we were still determining winner. We were trying to get the black as a winner. So the last test we had was this one, determine winner for black, while white plays last.
Yeah, determine winner, at least one cell won for black, and white plays last, and black wins. And we made it pass, because, so let's just make sure, we said board, make board, and we added a stone right to the right of the black territory, and another one just below. And then the white plays a stone that has nothing to do with that.
Right. And the way we made it pass was we just checked that this position here was surrounded by black. So, as you can tell from right here.
Yeah, it's fully surrounded by. Okay. So obviously this is only partially working, right?
Yeah.
Okay, so what scenario do we want to cover to make sure it's working better?
How about surround a different territory? That way it's not only 1-1. Like maybe another corner.
Okay.
Or or we could make it something more in the middle, not on a corner or on the edge.
Sure. Okay. Why did you write that test so I can exactly understand what you mean?
Okay, so maybe we'll just I mean, this would basically force us to.
Remember, you have the test.
Right.
Yeah.
So this would just force us to change our code to be more general, right?
So what assumption are we making right now that you're trying to remove?
This right here, the winner is the one that surrounds 1-1, right? So we just.
Oh yeah, the 1-1 is hard coded. Sure.
Right.
Okay. Good.
Scenario.
Just use tab.
Oh yeah. I'm not sure how to share it.
Well, we can say that it's a different. It's basically the same one as before.
Yeah.
But it's a different cell, right?
Right.
So we can say a cell, not corner cell.
Okay.
is 1. Not corner cell, 1 for black. Or, you know what, 1 for white. Now let's see that the white can win.
Okay.
And expected behavior, just tab to white wins. Okay?
Okay. So... So we can either just copy this part and make a territory for white somewhere else, or we just basically just have white by itself, so that it won't win by Komi.
Whatever is the simplest and most readable test.
I'm not sure if that's the simplest. So.
It's the simplest way to prove our point. That's what I'm trying to say.
Okay. Sure. So that's 3, and then we want.
So why do you want a black territory at all?
So that we can force, because if there's no black territories, then they basically win. Well, actually, no, you're right. Because the Komi is only if it's plagued, right?
By the way, a way to delete the whole line is Control-Shift-L for line.
Control-Shift-L?
Yeah.
Okay. That's cool.
So why don't you, yeah, okay. Where are you getting the result from? You started from the assert, and then you started again from the beginning of the test. I'm wondering why.
Because every time we type board before, it would always just give me the board object when I didn't define the board.
Sure.
But you're right, I should probably... And then I could define the winner.
Okay. So white territory this time should be surrounded in all parts, right?
Right. Or at the edge.
Well, let's do something a bit different. We don't want... the test specifically says not corner cell.
Okay. Alright. Let me finish this one.
So line 3, line 4. We also need line 4. Yeah, exactly. It's 2. The white territory is in 3. And now we need a 4 and 4, right?
Okay. So this is going to be...
Oh.
I think the way we wrote this is a little bit different from the way we wrote in the other tests. Because this was X, so we had X going this way, and this was Y. Y was going this way.
When you're saying this way, I can't see anything being selected, so I don't know what you mean. This way. What does this...
So,
can you make a selection so I can see?
So when we did right
Yeah.
here,
Yeah.
for X, we were going left to right.
Sure.
It was increasing left to right, and for Y, we were increasing top to bottom, which is different from the way we wrote it yesterday.
So why are you writing it differently?
Well, I think yesterday you started it that way, but I didn't correct you. So you started writing it 2 1 and then 1 2. So it should have been 1
Yeah,
2.
because X and Y are the opposites. Yeah.
And 2.
Wait, but hold on. Are you changing an existing passing test right now?
Yeah, so I should probably not do that, right?
Well, yeah. If you think that this test is wrong,
We should comment this one out first.
sure.
It's an easy way to comment.
Just control slash.
Control. Which slash?
Right slash. Forward slash. Yeah.
Alright.
So you think that test is wrong? So create the good version of it.
Oh, first I need to make it run. How come I'm getting
Alt R.
Alt R? I'm pressing Alt R.
Interesting.
Okay. So let's make a good
No,
version.
I think because there was nothing to repeat. So now if you press Alt R, will be a repetition. Alt R repeats. Did you duplicate the test now?
No, I did not. I just fixed it.
You fixed it back to the way it was.
Yeah.
Okay. But make sure that you run all the tests, not just one. I think you just clicked on a single test to run.
No, it ran 11.
Oh, okay.
So,
Okay. So duplicate the test, write it the way you think it should be written. Hold on. Are you fixing the second test now?
no, these are 2 different tests. This one and this one. We copied it over here.
Did you copy them? I didn't see that you were copying them. That's what.
Oh, I was not copying it. I was just switching the X and the Y.
But they're passing. To me, that feels wrong.
Well, I just make it so it's more consistent with the other tests. Or we can fix it such as that it makes sense.
I'm trying to understand why it feels wrong to me that you're changing an existing test. First
It's
of all,
because
well, I'll tell you what my guiding principle is. If something is
Okay.
passing, we want to know it continues to pass later. So if you're changing it, you're basically removing your tracks. That's why I like to
because
duplicate.
the reason why I was saying is inconsistent is if you look at these above tests. This is X. The 1 is X. The 3 is Y.
Mm-hmm.
And then the X, when we put it right next to it, the X increases, right? So originally it was 2 1. So basically, if we want to keep it the same as the previous test, the X on this side should be less than the X on this side.
Sure.
So I'm just worried that the person who picks up this test afterwards will be a little bit confused, like why is it different? Why is it positioned different?
Okay, I understand that. Run all the tests. Let's see what happens after you fixed it.
Okay, so it's the same as I guess I could have copied and pasted here and copy this one and paste it up there.
Sure.
I could have done that, but I think it said it all passed. Yeah, so 11 passed, 0 failed. We good to go?
Okay.
How do I is it slash?
Again, just the same the way you commented it. Control /.
Okay.
Okay.
So now that we have it consistent, we can
So we have X and Y.
2, and this one would be 3 1. This one would be 3 2. This one would be 3 3. And this one would be 4 2. Right.
I think it really helps now that it's visually arranged that way.
Right. Right.
Okay.
Okay, so we can run this. It's failed. Okay. So how do we want to update this?
So our current problem is that we have a hard-coded 1 and 1, right? We're always looking for
Right.
the let's see. Where we oh yeah, we extracted it to the rules, right?
Rules, right.
Okay. So 1 and 1 is no longer okay. So what's the simplest thing we can do to make everything pass? So you remember yesterday I told you, imagine you're the laziest developer in the world. You have to go in 5 minutes.
Yeah.
So here's another way to think about it. Imagine you're like your 13-year-old cousin who just started programming in C#. How would he solve it? Right? Because he also wants to go, but he doesn't have the knowledge of making something complicated.
Okay.
So just a way to think about these things. So where are we getting the 1? Right now, we have no idea where to look for, right?
I mean, we know that we can look at 3-2. Basically, do the same thing we did with the 1-1. But I'm not sure if we want to do that. That would be the simplest way right now the quickest way
To look at 3-2
Yeah.
as well.
Yeah.
Mm-hmm. Actually, you know what I'm thinking? I'm looking at this code right now. Is that we're always checking for black. We could have done the same exact test from before and removed the assumption about the color.
Yep, we could have done that too. Do we want to go back?
Because right now, here's what I think. In this current test, we changed 2 assumptions, both the color and the position.
Right.
So let's keep one of them. Do we want to
Okay,
keep the
so-
color or do we want to keep the position?
So let's comment this one out first.
I don't think we need to comment it. I think we got the test wrong. I think we need to either reverse it so that black is still supposed to win but in a different position, or that white wins in the original position.
Okay.
So
Alright, so let's just make it black then.
yeah,
Since
I
we
think
have
that
the
would be
setup.
easiest. So I mean, first of all, change the name of the test.
Non-core cell 1
For black. Yeah.
And black wins.
Yeah.
Okay.
Will that test fail actually?
Yeah, it'll fail. Because it's not at the corner.
Yeah, but it's the last player is white. Well, we have to make the last player white.
Okay. You're right. Right. Same reason why the other test passed.
Okay.
Actually, this actually cannot be the same. It's called 4.
Yep.
Okay.
What happens now?
Whoa. Why does it pass?
Interesting. So we got the test wrong. Interesting. We're expecting black and we actually get black.
Because current winner is last one added. Surrounded, return color.
Aha, so this is interesting. So we're not sure how to get it to fail.
Oh, okay. I think the easiest would be.
Actually, you know what? Here's why it's working, because that location is actually surrounded by black, isn't it? 1 and 1, isn't it surrounded now?
1-1 would be like right here, right? And then 1-2, and then 2-1.
Yeah, but when we check is fully surrounded by, I think we're also checking the ones right next to it as well. Is that possible? No.
You're right. Maybe actually I don't think so. I remember this.
You can. So here's a trick, by the way. If you want to go back.
Oh man, this. How do you go back?
Control minus.
Okay, that's what I did, but it didn't go back for me.
Interesting. Another way is to Control Alt F7.
Never mind, I lied. It went back for me.
Bastard.
Alright.
Control turns it into a link, and then you can click it.
Oh, control?
Yeah, Control, and then you just hover the mouse over anything, and it becomes a link.
Oh, wow, okay.
Yeah.
Interesting. Yeah, I'm used to pressing F12, but
resharper. Yeah, F12 or Control B will work as well. Control B and resharper. Okay, so we're getting something wrong here, right? We cannot. This test is wrong in one way, or the test is right, and our code is doing too much. I'm not sure.
I think the test is right, and there's something wrong with our code.
So we have to write a test that fails that proves that there is a bug.
Okay.
Do you agree?
I mean, I was thinking it might be easier to just walk through the code and find.
Yeah, I definitely think we can debug the code. What I'm saying is that we cannot change it because if you think it's obvious that there is a bug in the production code, we need to be able to later reproduce it with a test before we fix it.
Okay.
Agreed?
All right. I agree, but I'm not sure how.
Well, first of all, we have to realize what the problem is.
Right.
Okay. So what we can do is we can basically put a breakpoint here.
Oh, I see. So we do break into it, find out the problem, and then
write a test that recreates the problem.
I see. Okay.
Basic forensics.
All right.
So you go all the way up here, but I can't see it. You say test with debugger.
Okay.
Okay, so let's step into it. Let's see what happens.
In Komi should be false, right?
Sure.
Surrounded.
And is it just let's see what it returns.
Oh, I forgot what's the command to skip back up. This one.
Never mind.
Alright.
Just F10. Yeah.
So it says surrounded is true, so you are right.
Okay. So, but we can't just create a test that proves that is surrounded by returns true or false because that doesn't is not a unit of work. It's an internal thing. So the only thing we need to say is that something else doesn't work because of that. Something that we should have gotten a different result when we're getting a real one. So is fully surrounded by returns true. Let's see why it checks it returns true. Now we can actually jump into it with F11.
Okay.
Okay, let's just see which one returns true at some point.
Surrounded on left equals true.
Yeah, well that's okay.
Well, it's one, 1. Oh yeah, 0, 0, 1. Right, so that's
okay. Surround on right should be false. Let's see what happens. I can't see it. Surrounded on right is true. Interesting.
X plus 1 is, so this is 2, 2, 1. I'm interested in what the board is. So this is looking at the surrounded get stone color, so it should be, so everything is black, it says. I thought we made it so that everything is empty at the beginning.
So everything was supposed to be empty.
Right.
But
so I guess our test could be we initialize the board and we verify that it's empty.
That would be that would be one way, but I would rather verify that there is a bug where, for example, we have something that's not surrounded, and so the winner should be the other color, and we get the one that's wrong.
Okay.
For example, we can create a test almost like we have right now, But we have a stone that's not to the right. So there is no winner. So we should be getting a white by Comey, right?
I see. I see.
But because it thinks it's surrounded, it's going to be false.
I see.
Does that make sense?
Okay. Yeah, that makes sense.
And just to make sure, let's see what surround on bottom and top says.
Okay. It's
F10 and F10.
True.
Sorry?
It's gonna say true because.
Yeah, because everything is black.
Right. Okay. Alright. You want to write this test?
Okay, let's see. So what's going to happen is we're going to write a failing test. When we make that test pass, this test should start failing. And then we can fix it.
Okay.
Okay?
So you're gonna just add the test. You're not gonna comment it out.
No, this test passes. We're going to use it later when it stops passing. Determine winner. Black doesn't own any cell. White should win. But played.
Actually, I realized this one. Oh, okay. Oh, I see. I see what you mean.
Okay?
Okay.
It's different from a test we already have because the black is already played.
You're right. Black played, but doesn't own any territories. Right. Okay.
And in that case, we can say make board, add stone black at 3.1, and that's it.
Right.
I'm going to delete these 3 lines.
Actually, no, that would.
What? You think the white should have played already, right?
Right, but then I think you're gonna get white because the current winner.
Yeah, we're supposed to get white, but I think we're gonna get black. That's my point.
Okay.
Because everything by default is black.
I see. You're right. You're right. I agree. I agree.
So we're supposed to be getting white here, because by Comey we should be getting white.
Right.
Owning cell at once. White should win by Comey, right? Make sense? Or does Comey not play into anything?
No, it should be owned by Comey because neither of them own any territories now.
Okay, so Comey only stops applying when someone owns a territory.
Yeah, none of them own territories, so white should win.
Okay, Alt R. Yeah, it's debugging. Because that's what we did before, that's the last thing we did. So just right click here, run tests.
Cool.
Stayed white but was black. That recreates our problem. So now we can go ahead and say, oh, there is an initial board that's supposed to be, everything's supposed to be empty because our enum here, let's move our enum here for a second.
Good job.
Sorry?
You need to make it int, declare int, I forgot how you do that.
And int, enum is int by default if I remember correctly.
So well, why is it not setting it as 0?
Because we have to set the other ones.
The solution would be just move empty on the top.
Equals 1.
That will.
Sorry?
Or do that.
Let's see what happens.
I was going to put empty on the top. Oh, 2 failed now.
Black wins, black wins. But you notice that our test currently passes? The new one?
Yeah, the new one passes. Okay.
Right? Because in our test, white should have won.
Right. Right. Okay.
Okay, so we have one test which we expect it to fail, which is a not corner cell, right?
Right, that one we expect to fail. The first one, though, we expect to pass.
At least one cell, 1 for black and white. Well, at least one cell, 1 for black and white plays last. Black wins. Okay. So, I would suggest let's fix the. Let's comment out the test we have that we expected to fail, so we can focus on the one we didn't expect to fail. Which is this is the one we expected to fail, right?
Right.
Oops, that's not what I meant. Control Z. Control slash. You do it. Control // I think our keyboards are just different. Okay.
Maybe.
Alt R. Okay. Now let's see what the hell happened here. Double click here. And where are we?
We're at the top. Those are equal.
Oh yeah. Okay, so now we can actually debug that and see what happens. Okay. Oops. So you press F11. For me, it doesn't work.
Oh, really? Okay. Alright, so...
Okay, F10. Let's see. Is fully surrounded by, what does it say? False. That's okay. That's good for us, right?
No, it's supposed to be true.
But it's not. It's how is it supposed to be true? Oh, at least one cell, 1 for black. That's true. So we have. Did we get the test wrong? It thinks it's not surrounded.
I remember. Remember we were talking about how we did not. I was talking about how we did not have tests verifying that surrounded on the corner or on the edge, and then you thought maybe it might pass our implementation or took care of it, so we decided to go try other stuff first.
Okay.
So I think this might be relating to that, where we did not have tests originally to verify that checking in the corner that it's surrounded actually passes.
Okay, so why don't we step into is fully surrounded by and see exactly what the problem is.
Yeah.
F11, that sucker. Okay.
So surrounded left is going to be false. Oh, what just happened? What did I just do? Why do you look funny? Oh. F10. Surrounded is false. So I think the issue is that we're treating the boundary as 0 here.
Yeah.
Where
it should have been.
Where we wanted it to be 1 through 19 instead of 0 through 18. Like we didn't want the. I forget what's the term.
We should just say x is bigger than 1. No? X is smaller than 2, maybe.
Or x. Yeah.
Because x is 1 right now.
Right.
So if x is smaller than 2, then yeah, we're surrounded on the left. Or actually, just if x is equals 1, no?
Yeah. Yeah.
So it's the wrong 0, yeah. So x equals 1 would be the change here.
Okay.
And for surrounded on top, it's y equals 1. But let's see what happens. Let's just fix this one and see what happens.
Okay, so should we keep on stepping through or just run through the rest?
Whatever you think.
Just run through the rest since we already know what we want. Okay. So we know we want to fix this. Equals 1.
Mm-hmm. Let's see. Now, don't repeat. Just run all the tests with the menu for now. Because it will repeat the debug action. Yeah.
9 failed.
Wow. Awesome. What the hell? I think maybe a lot of our tests we treat x as y. Maybe that's the problem.
No, I don't think that's it. I think. Oh, so what's the ones I filled? Acetone above and surround opposite color. Index out of range. Index was out of range. Get stone color.
Because, well, how about x is smaller than 2? I'm not even going to try to fix everything. I'm just going to say if x is smaller than 2, maybe that's a simpler fix. And repeat. Okay.
Alright.
So at least one cell, one for black, and white plays last, black wins. So I think we should also fix the y for smaller than 2. Okay.
Good at pass.
Wow.
Alright.
Okay, okay, so let's uncomment the other test, and that should fail. Let's see.
Right.
Okay, so determine winner, not corner cell 1 for black. Black wins, but it was white.
Right. Because we're just
Because now we're back to fixing the 1 and 1, right? To fixing that hard-coded x and y for always at the corner. So now we can actually go and fix that, right?
Yeah.
Now that's the actual thing we wanted to try. We were yak shaving up until now. So that's our problem. Is surrounded by. We have a black that's surrounded, but it's not 1 and 1. Okay. So, what's the easiest way to find black as the winner? Remember, we assumed that black is the winner, so we just need to find that black has surrounded 1.
Well, the first easiest one would be just check this territory, but would we want to do that? Is that what you mean by simplest way?
Well, simple does not necessarily mean... well, remember, simple is, first of all, as close to the top of the method as possible and less indented. If we just check 2 places, it just leads us down a rabbit hole of continuing to check 2 places, 3 or 4 places. So assuming that it will be actually easier to and simpler to just write a loop that goes through everything, maybe.
Yeah, that's what I was. That was, I think, was the next simplest solution. So.
Actually, here's something simpler. What if we didn't use a loop? What if every time we added a stone, we would check if it's fully surrounded by?
Every time we added a stone,
we would check for around it if something is fully surrounded. Right? We already have a remove stone if surrounded, right?
Right. Right. So that means every time we add a stone for each of its neighbors, we check if it's surrounded.
Yeah, we already have the infrastructure in place. We just, in the place where we would have removed the stone, we would also just declare the winner as well, for now.
Okay.
What do you think?
I want to see you do it. I'm not sure if I fully understand.
Okay. So, remove stone is surrounded. Already knows if something is surrounded, right?
Yes.
So if it's fully surrounded, right now, we always assume that black is the winner, right?
Right.
So we just say...
But right now we're doing, is fully surrounded by white only in that code.
Sorry?
Right now we're only doing fully surrounded by white.
Ah, interesting. So that's another thing to take care of. But let's see. It's always fully surrounded by, so that's something we will need to take care of as well. So I would say also, so that we won't forget to do it later, we would say to do remove assumption that checks, that removes stones only if they are surrounded in white, because that's a bug. Right?
Right.
So one way to fix this is to actually to take that as a parameter, and then
Right.
Remove surrounded if. Because I'm pretty sure we have two ways to go about this at least. We can either do this, and then when we know that it's black, then just declare the winner. Or just, if someone has something fully surrounded, just declare that as the winner in the rules. Okay?
Okay.
I mean, rules is fully surrounded by is already sending stone color white. Agreed?
Mm-hmm.
Actually, yeah, we don't have to go far. We'll go to rules is fully surrounded by, and we'll say here, if fully surrounded, and last, what was it? Current winner equals surrounding. How's that hack for you?
Interesting. Alright.
Now, the get winner won't have to check if something is fully surrounded. It will just say current winner.
Right. So we would want to do if fully surrounded by in the add stone. Right.
We're doing that.
Right. Okay.
Okay, so we ran the test, 2 failed. At least one cell, 1 for black, and white plays last, black wins, failed. And not corner cell, 1 for black, black wins, failed. So either that didn't work, or I missed something.
No, I think you're only checking if fully surrounded for that current stone.
Whenever
don't
we
think
added
you-
position.
I think
Okay.
you need to check for the neighbors.
Okay, you know what? Let's do it simpler. Hold on. I'm gonna undo. Okay. Just this. And here, the simplest thing I can think of is just to do a loop over everything
Right.
and just count the points,
Yep.
basically. So for int I in what was it? Board
One.
dot.
Right, or actually,
Sorry. Oh yeah, equals 0 to, or is it 1?
1. Well, we're treating 1 as the edge. Right.
1. 1 is smaller than board dot. What was the name of that thing? Of that const size?
Yeah, I don't think it's public.
We'll make it.
And I think it's supposed to be while I is less than equal to. Cool.
Is that supposed to be public or private? Let's see. Nope, that doesn't. So I'm missing the name of that. Let's see. Board size was without an underscore. That's it. Okay. Make it public. And now we need an inner loop. Right?
Yep.
For and J. Is it the same, right?
Right. So we want to equal 1 also.
Yeah. It's not letting me there. So there. Ah.
Our board size right now is 20, right? So it should be.
Should be 19.
Is it 19?
Yeah.
0 to 9.
I think so. We stopped. We tried changing it, but we backed out on it, if I remember correctly.
Right.
We can go back there.
The thing is, if we want to treat the edge as 19, the array is 0 between 18, right?
Hold on. Yeah.
So when it does check the edge for 19, you're going to get an out of index exception.
We would say here, basically. We would just back out on the first surrounding. So we would say just come on. If it is fully surrounded by, we'll just use I and J. We would just say return stone color black. How's that?
Yeah. Yeah.
And now we don't need to do anything here. That makes sense?
Yeah.
Well, we'll
So
still have those two failed, but it's still index. So I guess we should be, yeah. Okay.
Index outer range. Get stone color.
Stone color. Where is that gotten from?
It's fully surrounded by. It's because I know why.
Okay.
It's because we were not checking the edges for right here. So right and bottom. We're not checking pivots. So this one should be.
Should be board size -1.
Right.
Smaller than board size -2, I guess.
Well, it's gonna be greater than, because we wanted to return true, right? Board size minus
1.
1. Why do we have?
Well, you still have to put it in brackets, in parentheses.
Do we have to put it in brackets?
I think it's more readable.
Okay.
It's bigger than board size -1. Actually, I would say it's equal to board size, or it's bigger than board size -2. I think it's the same deal. Because if it's bigger than board size -1, sure, okay, you know what? Sure. So let's debug this thing.
Alright.
But we can see exactly where we got the message. Here. Stone color, get winner. Then, we don't have a line number? Yeah, we do. Stone color matrix here. We get it from this line.
Okay.
Let's run it on bottom. Just this. You see? And there we have this one, and it's just -2. I'm awesome.
This does sound feel like we're kind of like just hacking our way through. Like
Oh yeah, definitely.
Logic together.
Well, it's more like a trial and error because this is, I mean, it's known to be like an error and an off by one error. So instead of just thinking it through, I'm just gonna let the compiler and the test let me know when I'm done. Okay. Because I know that the range is one here or one to the other way. So I'm not gonna bother thinking too much about it. If I realize that that's not the real problem, then I can start delving into it. But I'd rather just focus on like really difficult stuff. Here this is simple. It either works or it doesn't. And we know that this is where the line, this is what we changed. So it's kind of simple.
Okay, that makes sense.
Okay, so now that we have everything passing, let's refactor a bit because I don't like these number 2s there.
Yeah.
So we can make them into consts. At least. Right?
Say again?
So we can make them into const numbers.
Okay, right.
With a good name. What would a good name be, though? If it's smaller than, like the edge. Let's just call it edge.
Yeah,
let's just call it edge.
That does make sense.
Sure.
Okay.
So we can go ahead and say Control-Shift-R. Introduce variable or field. Replace for. Call it edge. Make it a static. It's not an edge, it's an edge. What's that? So he's fully surrounded by, surrounded on the left. We don't need to do this check. What else? So what did we just add? What feature did we just add?
We added in the...
we removed the assumption of 1 and 1, actually. Right?
You broke up a little bit there for me.
We removed the assumption of 1 and 1.
Right.
Hold on. Okay, so we removed the assumption of that black is always at the same location. Mm-hmm. We said if we had a black that's not in the corner, it would still be found as the winner. Yep. So now we can remove the assumption that black is always the winner.
Yep, we do that.
So we can say Control D, determine winner.
I think it might be easier if we copy one of the other tests.
Oh, did I copy the wrong test?
Yeah, the test above that one.
Sure.
And then replace it with
determine winner, not corner cell 1 for black. Black wins. But now we're going to remove a different assumption. Determine winner, not corner cell 1 for white.
Mm-hmm. And white wins. Yep.
White wins. So we're just gonna switch up the colors.
Yep.
White. What else is there? And actually this means black.
Yep.
Black, white, white, okay, and the last play is by black. Sure?
Yep. And then you assert are equal.
Oh, that's
white.
True. Alt-R.
Alright.
Okay. Determining winner, not corner cell 1 for white. White wins. Or, yeah, white wins. But it was black. So now you can just say, just return get, or is it board get stone color at I and J, right?
No, because it's fully surrounded by, it's going to return false because it's only checking if surrounded by black, not
I and J
white.
plus 1. Huh?
No, I don't think it's going to even enter in here because this is going to be false. Because it's looking if it's surrounded by black instead of white. So I think the easiest one would be if we go back, oops. If we do this.
Yeah, well, that will pass. It's pretty horrible, and then we'll make it nicer.
Yeah.
Yeah, I agree.
So this should pass, yep. Okay. Now, how do we make it pretty?
Now, I think we need the fully surrounded by not to take a color. That's basically it. We need to have a version of that where we don't care about the color anymore.
Right.
So imagine we did this. Fully surrounded by, and then we would just say is not equal to empty.
Right.
Stone color empty. Stone color empty, etc. So we have a version of this, and now we would go back to.
Would it be okay to change the return type? Well, I guess, like if it's fully surrounded by, it returns.
It's just a Boolean, isn't it?
Right. But I mean, it might be simple. Right.
Yeah, but imagine that it's partly surrounded in white and then partly in black. What would you return if you return a color?
Right. Well, I don't think that method right now actually solves that problem. But I think we might need to introduce a test to show that that fails.
That should fix it, I think. Did I forget something? What did I forget? Oh yeah,
First you need
here.
produce.
Just
And
a...
then, and
Might
also
have
you're
something to
only
do with the fact
returning
it's...
black right now.
Sorry?
Right now you're only returning stone color black.
Oh yeah, right. Good catch. And the fact that it's 3 a.m. here might delimit my abilities for a bit. Board get stone color at I, and well, it's surrounded by, but we can't assume that we get a surrounded by. But I'm gonna assume it's J plus 1.
Okay.
Let's see what happens. Yeah, that doesn't always work. Now I'm just toying with myself. So what do we do? We still need to get the other version.
Yeah.
What do you think?
I was thinking that the fully surrounded by can return the color if it's surrounded. Like maybe have an out parameter.
I think you had it right the first time. We just say is surrounded by stone color. I think that would be the most readable and simplest. I think that's
well,
just yeah.
I had two.
Yeah, and then you had 2, of course.
Right.
But it's still more readable and than anything more generic than that, I think. I mean, I kind of like it. I mean, I would have been nice to just do it in one.
Yeah.
But we can't assume that we know which color and from which side.
Right.
Agreed?
Agreed. You also might need to change back to the.
Just
original-
remove that. I'm gonna remove the other is fully surrounded by.
Yeah.
Come on. There it is. Okay. So, but we still have an assumption here, right? The assumption is that whoever has won any kind of territory is the winner.
Yep.
So we need to start counting territories, right?
Yep. So what we can do is we can have.
But first of all, let's commit.
Okay. Our shopper.
You'll do a git ignore for that later, right?
Yeah, should I ignore those stuff? Our
But
shoppers?
not for now, because I think we're gonna break for now. It's been an hour. I'm gonna go to sleep, and we're gonna continue at a different time.
Alright, so what should I name this?
Winner by color and position. Territory position. Yeah, okay, but not with count.
Okay.
Sure.
Alright, cool.
Cool. Okay. Thanks, Raymond. I'll see you later.
Alright.
Bye, everyone.